All right, so today our lesson is about creating scatter graphs, and our objective is to draw an appropriate line of best fit on scatter graphs and use it to make estimates. So, how do we draw a line of best fit on our scatter graph? First of all, let's look at what we mean by line of best fit. A line of best fit roughly follows the pattern of the point, and it does not have to go through any point or start on the axis or start from the origin. So this is what we mean for positive correlation, for negative correlation, and for no correlation. So sometimes points on the scatter graphs are represented by a trend line. We also call that the line of best fit. So when we are drawing a scatter graph, we need to draw a line of best fit on it. So to draw the line of best fit, you want to get the point as close to the line as possible. Now, I quite understand that you may find it difficult to have almost the same line of best fit for everyone, but the idea here is to get the point as close to the line as possible. So you don't need to worry much about making your line of best fit perfect. We have a sort of tolerance, and so we make sure that your line of best fit is in a suitable region. All right. Just make sure that your line of best fit is close to the point as possible. It doesn't have to go through the origin. So this is what we mean by line of best fit. So line of best fit can be used to make predictions. That's what we do with line of best fit. So after plotting your points on the grid, and after telling us if it is positive correlation, negative correlation, or no correlation, then we need to draw a line of best fit, because we use the line of best fit to make predictions. And remember, I said that you don't have to worry much about making your line of best fit perfect. Okay? Just try as much as possible to get the point as close to the line as possible. That's all you need to do. So take for example this one. This is example one. Plot the data on the graph such that homework time is on the y-axis and the TV time is on the x-axis. So we have the time spent on watching TV for Sam and the time spent on homework for Sam as well. So we have the following information and we want to show this on the graph. So this is what we would have for a graph. This is what we're going to have for the graph. Yes. Now you discover that in this case, the trend appears linear. You have a downward trend. The trend is decreasing. Okay. As the time on TV increases, you have the time on homework decreasing. So to draw your line of best fit, just try as much as possible to get points as close to the line. Okay, you don't need to draw the line such that it should meet all the points. Just make sure that you have your line very close to the points. Okay, so and it's a negative correlation. So how do we use the line of best fit to predict? You can be asked to use your graph to estimate the time spent watching TV in the week if they spend 60 minutes on homework. So you go to the homework, which is on the y-axis, you trace 60, and you trace down to where you have the time watching TV. So you trace from the y-axis to the x-axis. So you discover that roughly on an estimate you have 200 minutes. Just like I said, we do not expect that you have the same answer, but of course we have a sort of tolerance, so you should get your answer between a certain range. Okay, here's example 2. Draw a scatter graph to illustrate this information. Label the horizontal axis as year and the vertical axis as vehicle sales. Is there any correlation? If so, what type? So we took this before, and we're going to draw our scatter graphs just like we did in the previous lesson. For each of them, we're going to take each of them as a pair of coordinates, 90, 91, and 0.9. And when you're done, your graph should look just like this. So, as you would see, the trend appears linear and the trend is increasing. So it is a positive correlation. Just like I said, you draw your line of best fit. Try as much as possible to get the point as close to the line. Okay, so it is a positive correlation. So how do we make predictions using a line of best fit? Here's it. We want to use our graph to make estimates to estimate the vehicle sales in the year 2000. So you draw your line. In the year 2000, you'd have a vehicle sales of 3.35 million on an estimate. So just trace the point just right up until you get to the line of best fit. Then you trace it over to the vehicle sales, and you have approximately 3.35 million in the year 2000. So, for example, in this case, we want to use the line of best fit to predict how many outbreaks may be reported in the US in 2015 if the trend continues. So here's a scatter graph showing the outbreaks in different years as shown. So we want to use the scatter graph to predict how many outbreaks that will be reported in the US in 2015 if the trend continues according to the graph. So you trace the point from 2015 and you trace it over to the outbreaks. So approximately we should have 1,200 outbreaks reported in 2015. So this is how to use your line of best fit to make predictions. Okay, all you need to do, you follow the steps, you plot your point on the grid, you tell if it's a positive correlation, if it's a negative correlation, then you draw your line of best fit. Okay, just make sure that the line of best fit is close to the point as possible. You do not need to worry about the fact that all the points must follow the line. Okay, and that is what you have. So in summary, for positive correlation, the points lie close to a straight line which has a positive gradient, and this shows that as one variable increases, the other increases. And for negative correlation, we have that the points lie close to a straight line, which is our line of best fit, which has a negative gradient. So this shows that as one variable increases, the other decreases. And finally, no correlation, there is no pattern to the points. You have it randomly scattered around the graph, and this shows that there is no connection between the two variables. So that is it for today. Thank you so much for listening and have a good day.